Hello, I am Seema and welcome to part 43 of the chapter Organic Chemistry, Some Basic Principles and Techniques. We have been doing the quantitative analysis of organic compounds. And in the previous video, I told you how do we find out the percentage composition of nitrogen in a compound if nitrogen is present in the compound. And I told you that there are two ways of estimating the quantity of nitrogen. The first method is known as Kjeldahls method, which we did in the previous video. And from this video onwards, I'm going to take up the second method, that is Kjeldahls method. So I'll be doing two videos on this, and in this video, I'm going to basically explain how it is done, and I'll take it further. I'll continue it in the next video. So let us begin what Kjeldahls method is. But before we come to Kjeldahls method, let us just revise what are we trying to do. When we wanted to find out what the organic compound was when a sample is given to us and we want to find out what the organic compound is, the first step is that we try to estimate which elements are present in the compound. That is known as a qualitative analysis. After we come to know what are the elements present in the compound, we have various tests to identify different elements. Then, in the next step, we carry out the quantitative analysis. In quantitative analysis, we find out, okay, these are the elements present in the compound. What are the mass percentages of each of these elements? Once we know the mass percentages of each of the elements, it is possible for us to estimate the empirical formula of the compound after testing in the laboratory the functional group that is present in the organic compound. And once we do that, we can find out the molecular mass, and once we know the molecular mass and the empirical formula mass, from that we get an idea of the molecular formula of the compound. So these are the different steps. It's a very detailed process which involves all these steps in order to identify the compound. We are doing Kjeldahls method, that is, we are now going to find out the second method of how do we estimate the mass percentage of nitrogen in a compound. In Kjeldahls method, what we did, we prepared ammonia, and this ammonia was collected as a gas, and that gas ammonia was measured, the volume occupied by it was measured, and we estimated the mass of nitrogen from that volume. In Kjeldahls method also we prepared ammonia, but we do not calculate or trap the gas and find out the volume of the gas. Rather, we carry out the conversion, or we convert the ammonia that is formed into a salt, that is ammonium sulfate, and then we estimate the nitrogen present in it. So this it's just, instead of handling the gas and calculating from there, we are converting it into a soluble liquid, and then we are going to estimate it. Just a little difference in the method, but the aim is the same. Our aim is to find out the mass of nitrogen present in a certain mass of the compound that we took, right? So what do we do in this? The compound is heated with concentrated H2SO4. This reaction, or rather this method, involves steps. The first step is that nitrogen is present in the compound. We make it react with, we heat it up with concentrated sulfuric acid. And if any nitrogen is present in it, it will result in the formation of ammonium sulfate. Right? We prepare ammonium sulfate from the compound that has nitrogen by making it react with concentrated H2SO4. This ammonium sulfate that is produced, we want to separate out the nitrogen from it. We want to separate out the ammonium sulfate. That is, we carry out these steps in order to isolate the nitrogen so that we can then estimate it and not get confused by the presence of the other elements which may interfere with our measurements and reactions. So now this ammonium sulfate that is produced, it is present in the mixture. We took the organic compound and some concentrated H2SO4, a little copper sulfate, and we heated it with, and the basic reaction is between concentrated H2SO4 and the nitrogen containing compound, resulting in the formation of ammonium sulfate. Now this resulting acid mixture is then heated with excess of sodium hydroxide. When you carry out, you take the contents of this flask, we put it in another flask, and now we heat it up. Heat this round bottom flask, and this is known as the Kjeldahls trap you see a delivery tube here. The delivery tube allows the formation. When gases are formed, they would rise and they would go through the delivery tube and will be collected in another apparatus. Here you have the condenser which has been attached here. It comes into this funnel. A condenser is attached and it comes down, and in this flask, or in the conical flask, we have a known volume of a standard acid. What does that mean? Known volume means we have measured the volume exactly, and it's a standard acid. Standard acid means that we know the strength of the acid. We are going to take an acid, again it is going to be sulfuric acid, and this time we know the molarity of the acid and we are taking a fixed volume of it. That means our quantitative estimation is going to start here. Exactly what quantity, that is going to help us, and that is why we need a standard solution, that is whose molarity is known to us, and a fixed volume of the standard solution, so that we know how much of it is used in order to estimate the amount of nitrogen present. So what happens? So the resulting acid mixture is heated with excess of sodium hydroxide, and when this happens, ammonia gas is liberated. So ammonia gas is liberated and it travels through the tube and comes here, gets condensed and enters the acid solution. When ammonia reacts with sulfuric acid, it results in the formation of ammonium sulfate. Now, you may get confused why we got ammonium sulfate in the very first step. So why did we carry out this entire, a big apparatus and repeating the process, just making it complicated for no reason? And in the end, all I got was ammonium sulfate again. So why did I do all this? The reason for it is that my idea was to isolate the nitrogen. The compound here may have had other elements which would also react with sulfuric acid, and they may interfere with our measurements and reactions. Therefore, it was important to isolate the nitrogen containing compound, and you could not have converted ammonium sulfate would be soluble in the liquid, but ammonia, when we heated it with sodium hydroxide solution, it resulted in the formation of ammonia gas, and the gas can be collected. So by doing that, we isolated the nitrogen. That is why, although we get ammonium sulfate twice, do not get confused. Why did we not straight away take the ammonium sulfate here? We had to separate it out from the mixture, which we did by converting it into ammonia. And now, whatever nitrogen was present gets converted into ammonia in the compound, in m grams of the compound, would get converted into ammonia, and that ammonia would get dissolved or would react with the sulfuric acid present in this flask, which has a known molarity, which has a fixed known volume to us, and that gets converted into ammonium sulfate. And since we take a lot of this standard acid, that is, all of it is not used, some of it will remain unused. From this solution, we can calculate how much of the acid was used up to form ammonium sulfate. We don't know how much ammonia is produced, but we know how much acid we took. So from the reaction, you will know after the reaction occurs where ammonium sulfate is formed, you can find out by titration what is the amount of sulfuric acid that was not used up, that remained unused in this reaction. When you find out the volume that this was not used during the reaction, it means that is the volume of the acid that was used up in the titration. I know this sounds a little confusing, but as I explain it to you, it will become clearer to you. Some of the acid is used up to react with ammonium sulfate, right? And some of the acid remains. It is not used up, it is unused in this reaction. This unused sulfuric acid will be titrated, will be estimated by titrating against a standard base. Since this is an acid, we use a standard base. When we say standard base, what does it mean? You could take sodium hydroxide, a base that is standard, whose molarity is known to you. And by titration, we'll find out what is the volume of this known standard acid which was not used in this reaction. Since we took a measured amount, some of it was not used and we found out what was not used. From the total amount, if you subtract the volume of the acid that was not used, you will get the volume of the acid that was used up. From the volume of the acid that was used up to prepare ammonium sulfate, you will know how much ammonium sulfate was produced. And exactly from that much of ammonium sulfate, how much nitrogen is present, you will be able to calculate. And that is the aim. The aim is to reach that nitrogen, find out how much of it is present in the compound, and then we can calculate its mass percentage. So that is how we go about the Kjeldahls process. It sounds a little complex, but if you just repeat it 2-3 times, just calmly go through the process, go through the steps, it will become clear to you. And once it is clear, there is no going back. So like they say, once you know something, you cannot unknow it. You will always know it. So the resulting acid mixture is heated with excess of sodium hydroxide. The liberated ammonia is absorbed in an excess standard solution of H2SO4. The amount of ammonia produced is estimated from the amount of H2SO4 consumed. How much H2SO4 was used up here will tell you the amount of ammonia that was absorbed. The amount of ammonia produced is estimated from the amount of H2SO4 consumed. This is done by titrating the unused H2SO4 against the standard alkali solution. Standard is whose molarity is known to you, and alkali would be a water-soluble base like sodium hydroxide. The difference between the initial amount of H2SO4 and the final amount will give you the amount of H2SO4 that reacted with ammonia. Now half of it was used up in titration and half of it was used, not half, some of it. Some of it was used up in titration. That was the amount of H2SO4 that was not used to make ammonia. So obviously that is the amount of that was not used in titration is the amount that was used up in formation in reacting with ammonia to form ammonium sulfate. From that we can reach the ammonia and we can tell what is the mass of the ammonia, that mass of nitrogen. We'll first find out how much of ammonia was there, and then we'll find out what was the mass of nitrogen. So what are the reactions? We take the original organic compound, the nitrogen of the organic compound combines with concentrated H2SO4 results in the formation of ammonium sulfate. Now this ammonium sulfate is then taken here, the entire mixture is taken and made to react with sodium hydroxide. So in the entire process we are using sulfuric acid and sodium hydroxide twice. In the first step, we used sodium hydroxide to convert it into ammonia, the ammonium sulfate. And then when it's kind of a reversible reaction. You make it react with sodium hydroxide, it will result in the not exactly reversible, but you'll make it react with the acid to give you back the ammonium sulfate. So ammonium sulfate reacted with sodium hydroxide to give you ammonia. Then ammonia that is produced will react with sulfuric acid and give you back the ammonium sulfate. So these were the chemical reactions that took place in different steps. Let me just repeat. First step, you take the nitrogen in the compound and sulfuric acid, it will result in the formation of ammonium sulfate. Second step, you take this mixture, put it here, add sodium hydroxide to it. The ammonium sulfate that was produced will react with sodium hydroxide, result in the formation of ammonia. So ammonia is produced. This ammonia, the rest are just byproducts. You are interested in the ammonia because we are targeting the nitrogen. So now this ammonia that was collected is made to react with a standard solution of sulfuric acid. It will give us ammonium sulfate. Then after you get this, you will be using the next would be the titration that you carry out in the laboratory, the acid-base titration. You are now left with H2SO4 and you need to find out how much H2SO4 is left. That you will do by titrating it against a base, that is sodium hydroxide solution. That is now used to estimate the H2SO4. Right? Now to explain the mathematical part, I'll just wipe off this side and then I'll explain this to you. Give me a minute. Alright, so let us now come to the mathematical portion. We are now interested in that final flask that we had here. You remember the final flask, the conical flask, in which we took sulfuric acid, right? Let us say we took this much of sulfuric acid, H2SO4. And let us say, since it was a standard solution, we know its molarity, and let us assume that the molarity is M. Okay, we took H2SO4 of molarity M, and in this the ammonia came in, and half of it, let me change the color here. Yeah, let us say that half of this sulfuric acid was used up with ammonia, right? And this half remained unused. So it is this unused H2SO4, this was used up with to form ammonium sulfate, NH4 whole twice SO4. It's just, it doesn't happen this way. I'm just telling you that some of it was used, it'll be distributed all over. But some of it, this volume, let us assume, of this molarity was not used, right? Our interest, we are now going to calculate this amount, what was not used. So let us say that the organic compound that we started with was m grams. We started with m grams of the organic compound. The volume of H2SO4 of molarity m taken was V ml. Now this H2SO4 that we took, total, all of it, was V ml. Okay, we took V ml of the organic of H2SO4. The volume of NaOH of molarity m that was used for titration of excess of H2SO4 is V1 ml. The volume of NaOH used for the titration. Now, when we had, what is the acid-base equation? H2SO4, the neutralization reaction that's going to take place, H2SO4 plus twice NaOH will give you Na2SO4 plus 2H2O, right? This is the neutralization reaction of sulfuric acid and sodium hydroxide. For every 1 mole of sulfuric acid, for the neutralization of 1 mole of sulfuric acid, if they both have the same strength, if both are of molarity M, if they have the same molarity, this is 1 molar, this is, so for every 1 mole of H2SO4, you need 2 moles of sodium hydroxide solution, right? So now we say that the total volume of H2SO4 that was taken was V ml. Now the volume of NaOH of molarity M, which was used for titration of excess of H2SO4, was V1 ml. This one, sodium hydroxide, is V1 ml. The volume of the sodium hydroxide taken for the titration is V1 ml. So if V1 ml sodium hydroxide has been taken, whatever is the milliliters, how much of H2SO4 would it be neutralizing? If this is, according to this, you need twice NaOH. If you have 1 mole of H2SO4, you need 2 moles of NaOH to neutralize it. So if you're taking V1 milliliters of sodium hydroxide, how much H2SO4, what would be the volume of H2SO4 in, according to this stoichiometry? It would be V1 by 2. Do you understand? How much would be H2SO4 used? If V1 ml of NaOH has been used up for the titration, it means that the volume of H2SO4 should be of the same strength, should be V1 by 2, should be half of it. So we say the volume of NaOH of molarity M used for titration of excess of H2SO4 was V1 ml. V1 ml of NaOH of molarity M will be equal to V1 by 2 ml of H2SO4 of molarity M. All this is happening if the molarity is the same. We took the H2SO4 solution of standard solution, its molarity was a specific molarity. So we took the sodium hydroxide solution of the same molarity. So if it is the same, then it would be the volume of H2SO4 would be V1 by 2 of the half of the volume of the NaOH that was used. From this, if this is the V1 by 2, then what is V1 by 2? This solution, this volume, that is this half is V1 by 2. Right? This half is V1 by 2. If this half is V1 by 2, then if this is half of it, this is V1 by 2. That is that half of H2SO4 that was not used up in the formation of ammonium sulfate. So what was the volume of H2SO4 used up in reaction with ammonium sulfate or with ammonia to form ammonium sulfate. Total volume was V. Total volume was V minus, what's happening to my pens? The total volume, okay, the total volume was V, and from the total volume minus V1 by 2. That is the volume of H2SO4 that was used up in the titration. So total volume minus the volume used up in H2SO4 for the titration will give you the volume of the H2SO4 used up to react with ammonium sulfate. You know, in the NCERT textbook, they have called this the volume unused. And that can create a little confusion for students. But the truth is that when he's talking of unused, he's talking of unused for titration. In other words, it is used for reaction. The one that is unused for titration was the one that was used up to react with ammonia. So I would have preferred, honestly, I would have preferred to use used here, because our main focus is not the titration, the process of titration. Our main focus is the process of formation of ammonium sulfate. So I would have called it used. Anyway, this is how it has been given in your NCERT, but you have to understand what it actually means. So volume of H2SO4 of molarity M that was unused or used up in reaction with ammonia is V minus V1 by 2. It is not V half, it is V1. V1, whatever is the volume of sodium hydroxide. So half of that is the volume of sodium hydroxide that is used up in V half. V1 by 2 is the volume that is used up in titration, and V minus V1 by 2 is the volume that was used up to react with ammonia. So V minus V1 by 2 ml of H2SO4 of molarity M, the molarity is important. The molarities should be equal to twice the same volume, twice of this volume of ammonia. Now, to understand this step, you need to look at this reaction. H2SO4, the stoichiometry of this reaction. 1 mole of H2SO4 reacts with 2 moles of ammonia, right? So what have we found out? How many moles of H2SO4 reacted? How many moles were they? They were V minus V1 by 2, right? That was the volume of ammonia, of H2SO4. That was, V minus V1 by 2 is the volume of H2SO4 that reacted with ammonia. But whatever is the volume of H2SO4, the ammonia is twice that volume, is 2 times. Do you see the stoichiometry here? So from this you will come to know if whatever is the volume, the ammonia would be twice of this. So it will be 2 into V minus V1 by 2. I hope I'm clear. So it is twice that amount, twice V minus V1 by 2 ml of ammonia of molarity M. Now from this we will come to now we have found out the volume of ammonia, right? The exact volume of ammonia of the solution containing ammonia. From that we'll say that 1000 milliliters of ammonia solution. What is the weight of 1000 ml of ammonia solution? The weight is 17 grams, right? If it is 1 molar. If it is 1 molar, if 1 molar solution 1000 ml means 1 liter. So 1 liter of ammonia solution, 1 molar unimolar solution should have 1 mole of ammonia in it. Since it has 1 mole per liter, that is the molarity, then 1 liter of ammonia or 1000 ml of ammonia solution should have 1 mole of ammonia, and the mass of ammonia 1 mole is 17 grams. Out of those 17 grams, how much is nitrogen? Hydrogen is 3 grams. There are 3 hydrogens. So the remaining is 14. So the mass of nitrogen in 1 mole of ammonia is 14 grams. So we'll say 1000 ml of 1 molar ammonia solution contains 14 grams of nitrogen. Finally, we have reached nitrogen and the mass of nitrogen. And from here the excitement begins. So now we use unitary method and we say that 1000 ml of ammonia solution contains nitrogen equal to 14 grams. So 1 ml will contain how much? 1 ml will contain 14 upon 1000 grams of nitrogen. And what is the volume that we had calculated? Twice V minus V1 by 2 ml. Twice V minus V1 by 2 ml of ammonia will contain how much? 14 upon 1000 into twice V minus V1 by 2. And what is important here? That if the molarity of ammonia is something different, we assume that it is 1 molar ammonia, right? We said that it is 1000 ml of 1 molar ammonia. If the molarity is not 1 molar, it is something else, it is m molar. So what will it be? For 1 molar ammonia, it is 14 by 1000. But for m molar ammonia, it will be into m. So you will multiply this by the molarity, right? So you will get 14 into m. 14 is the mass of nitrogen. M is the molarity of the solution. This is the volume of the H2SO4 or ammonia that was produced upon 1000, and that will give you the number of grams of nitrogen or the mass of nitrogen. Now that you have reached the mass of nitrogen, so we'll say that M, what was the compound that we took? We took m grams of the compound, right? We took m grams of the compound. M grams of the compound has how much? How many grams of nitrogen? Has nitrogen 14 into m into 2 V minus V1 by 2 upon 1000 grams of nitrogen. So if it was 1 gram, how much would it be? You will divide it by m. And if it is 100 grams, how much would it be? Into 100. This will give you the mass percentage, right? So 14 into m into 2 V minus V1 by 2 upon 1000 into 100 upon m will give you the mass percentage of nitrogen. So if you just remove the zeros here, you get 1.4 into m into 2 V minus V1 by 2 upon m. That's just a different way of writing it. So with this, I'll wind up today's video. I'll carry on this discussion in the next video. So we'll be finishing Kjeldahls method in part 44. So wait for that part to come. With this, I'll wind up the video. Thank you for watching and bye-bye for now.